calculate the expected value, variance and standard deviation for the probability distribution shown here. Now note, I've deliberately chosen one that is symmetrical. Therefore, we know that the expectation is going to be 2. It's going to be right in the middle. Now, to calculate the variance, we know that we need to do the expectation of x squared, take away the expectation of x squared. And the expectation of x squared is just going to be 1 squared times 0.25 plus 2 squared times 0.5 plus 3 squared times 0.25. And we can see that that is 4.5. And therefore the variance is 4.5, take away the expectation of x squared, which is going to be 0.5. The standard deviation of x then is the square root of 0.5. And let's just quickly calculate that. And that's going to be about 0.707. If we just go to 3dp. Okay, so we've got those results. And let's move on. We're now going to consider the probability distribution of y, which is shown here. Write a relationship between x and y in the form y equals x plus. Well, if we think about x took values 1, 2, and 3. This one takes 6, 7, and 8. So I'm going to say that y is x plus 5. We now want to calculate the expected value, variance, and standard deviation for y. Now, the expected value, once again, by symmetry, is just going to be in the middle. So the expectation of y is going to be 7. To get the variance of y, we can do the expectation of y squared, take away the expectation of y squared. And I'm just going to pause while I do this because you've seen me do this a few times already. So you can see it here on the calculator. I've done the expectation of x squared, which is 6 squared times 0.25, plus 7 squared times 0.5, plus 8 squared times 0.25. That gives me 49.5. And then I do that, take away the expectation of x, which was 7 squared, and that gives me 0.5. Which you'll notice is the same answer as we got up here. And that means that the standard deviation of y is going to be 0.707 to 3 decimal places, just like it was up here. Write a relationship between the expectation of x and expectation of y in the form expectation of y equals. Well, the expectation of y was 7. And that's equal to the expectation of x, which was 2, plus 5. Write a relationship between var x and var y in the form var y equals, well, they were the same. So var y is equal to var x. Write a relationship between sdx and sdy in the form sdy equals. Again, they were the same. So sdy equals sdx. What do we notice? Well, we just simply added 5. it changed the expectation by 5. In other words, the expectation of y was equal to the expectation of x plus 5. But no change to the variance or the standard deviation. Remember, these are measures of dispersion. The expectation is a measure of center, related to the mean. And if we go back here to the original distributions, we can see that simply these values have moved upwards by 5, which changes the location of the mean, but the actual spread is the same. 1, 2, 3 with these probabilities, 6, 7, 8 with the same probabilities, those are equally dispersed.